Hey everybody. All right, this is the last packet as part of the review. Uniform triangles. Let's get right into it. All right, so classify each triangle, be as specific as possible. Okay, so there's no picture here, so we'll just draw one, I guess. So ABC, A is 45, B is 90. So if one's 90, we know it's a right triangle, right? So that's going to be B. A is 45, so this is 45, means this has to be 45, so it's actually an isosceles right triangle. So it's isosceles, it's right triangle. Okay. I wonder if a picture got cut off or something. Oh, actually, I think it's forcing us to draw it, which is fine. So ABC, we have 60, 42, 78. So 60, 42, and 78. So 60 is A, B is 42, 78 is C. So they're all different, so it's scalene. All the angles are different, which means all the sides are different. And they're all less than 90, so it's scalene and it's acute. Okay. For C here, all three are different, so it's scalene. And they're all less than 90, so it's going to be acute. So this is actually very similar to B. Okay, over here, all three are different, so it's going to be scalene. And one of the angles is larger than 90, so it's going to be scalene and obtuse. Okay. In the figure, angle 1 is congruent to angle 2. So these are congruent. Find the measures of the numbered angles. Okay, so let's start over here. We can figure out what this angle is here. This is 70 and this is 65, because these three would have to add up to 180 because of triangle sum. So 70 plus 65 is going to be 135. And subtract that from 180. And we're going to get 45. That means this is 45 degrees. And now we can figure out what this is, because all three of these form a line, so they have to add up to 180. So 110 plus 45, and that's going to be 155. So subtract this from 180, we're going to get that. So 180, shift this up a little bit, there you go. 180 minus 155, and that's going to be, what, 25? So angle 1 is 25 degrees. So angle 1 is 25 degrees. And then this is the same, so this has to be 25 degrees as well. Angle 2 is 25 degrees. So they add up to 50, which means this has to be 130 because they have to add 180 degrees. So measure of angle 3 is 130 degrees. That's it. Okay. In each of the figures below, solve for x. This got cut off a little bit. Let's see. So we're solving for x for these triangles. So we're going to use triangle sum here. There's some room here. So 63 plus 83 plus x plus 35 equals 180. So we're going to combine the 63, the 83, and the 35. So 63 plus 83 would be 146 plus x plus 35 equals 180. And then 146 plus 35 would be, let's see, 11, carry the 1, 181, I think. Is that right? 70, yeah, 181 degrees plus x equals 180. Subtract 181 from both sides. And that's going to be x equals -1. We're just solving for x, right? Yep, we're solving for x. Okay, so over here, we're going to solve all these the same way, really. So 50 plus 85 plus 7x plus 3 equals 180. So combine these all together. So 50 plus 85 is 135. No, it's not. What am I saying? 135. Yeah, it is. It's 135. So 135 plus 3 is 138. Plus 7x equals 180. And then we're going to subtract 138 from both sides. So 7x equals 42. And then divide both sides by 7. And x will be equal to 6. Okay. So we're going to use external angle theorem here because we know these two angles add up to the external angle. So 22 plus x equals 146. Subtract 22 from both sides. X equals 124. And then this is x, so because it's an isosceles triangle, these are the base angles. So 50 plus x equals 180. So 50 plus 2x equals 180. So subtract 50 from both sides. 2x equals 130. Divide both sides by our coefficient, which is 2. And x should equal 65 degrees. Okay. Use the figure below to find x and y. Let me zoom out a little bit here, some more room. Okay. Okay, well, you know this is 79 because they're vertical. So that's 79. And then we can find y. We can do this two different ways. We're going to find the internal angle first here. So these three add up to 180. Or you could add these together to find that because external angle theorem. So 43. Let's do that. Why not? 43 plus 79. We'll use external angle theorem. So 3 plus 9 is 12. Carry the 1. 5. 122. So this is 122 degrees. And we know they're supplementary because they're a linear pair. So 180 minus 122 would equal 58 degrees, right? Yep, 58 degrees. There you go. Okay. All right. Pause it for 1 second. Okay. Can a triangle be formed from the lengths of a given length? Okay, so in order to figure this out, you take the two small sides, you add them together, and if it's larger than the third biggest side, then yes, it can be a triangle. So the two small sides are 32 and 24. So 24 plus 32 is 56, which is larger than 40. So yes, it can be a triangle. 4 and 10, because of the two small sides, so 4 plus 10 is 14. That is not bigger than 18, so no, it cannot form a triangle. The lengths of two sides of a triangle are 11 and 13. What can you conclude about the length x of the third side? Oh, sorry, let me zoom out here. So 11 and 13. So we're going to basically add and subtract them to get the range. So 11 plus 13 is 24. And 13, we do big minus small. 13 minus 11 is 2. So it has to be between 2 and 24, but not inclusive. So we're doing the exact same thing here. Yeah. 6 plus 18 is going to be 24. And then 18 minus 6 is 12. So it's between 12 and 24. Okay. Order the sides from CDE from shortest to longest. Okay, so this one you definitely want to draw the triangle. CDE. So C is 45 degrees. D is 75 degrees, and E is 60 degrees. So you take the smallest, because we're going shortest to longest, okay. Smallest angle C, so the side opposite it is this one right here. So ED is the smallest. And then the middle angle is 60 degrees, so that means this is the middle one. So CD is the middle one. And then D is the biggest angle, so that means CE would be the biggest side. Name the longest side of ABC, and they give us 2 of the 3. Okay, so let's draw this. So ABC. So A is 72 degrees, B is 53 degrees, and we don't know what C is. So we need to find C first, as they actually give us a hint here. So 53 plus 72 is 125, and subtract that from 180, and that's going to give us 55. So this is 55 degrees. So the biggest angle will be opposite the biggest, the biggest side will be opposite the biggest angle, which in this case is A. So that means this side is the biggest, BC. Okay. ABC is isosceles, with AB being equal to BC. Name a pair of congruent angles in this triangle. Okay, so we're going to look for the base angles here. Okay, so AB and BC. So AB, BC, so trying to make it actually look the way it should. Okay, so these two are the same, A, B, and BC. Name a pair of congruent angles. So the congruent angles will be the base angles, which are down here. So angle A is congruent to angle C. again, drawing these makes it doable. If you don't draw on these, you're going to be having a tough time. Okay, last two. Find the measures of B and C. So C has to be congruent to this because they're base angles. So that means they're 34 degrees. So 34 plus 34 is 68. Let's subtract that from 180. It's going to become 7, 2, and then 112. So angle B, measure of angle B is going to be 112 degrees. The measure of angle C is going to be 34 degrees. This looks to be an equilateral triangle, so all the angles will be congruent. So it means we can, and they're all going to be 60. So x minus 20 equals 60 degrees. Solve for x. We're going to add 20 to both sides. X will be equal to 80 degrees. And that's it. So that concludes the last of the review packets. Hopefully that was helpful for you guys. Again, if you have any questions, just shoot me an email, and I will get back to you as soon as I can. All right, thanks, everybody.